Welcome, dear listener, to another quiet evening beneath the soft canopy of the stars. I'm glad you're here, settling into this gentle corner of the universe where curiosity moves slowly and the night unfolds like a calm, celestial tide. As the world around you begins to dim and soften, you're invited to drift into a space where science becomes soothing, where ideas float like starlight, and where the cosmos is not something distant or overwhelming, but something peaceful, patient, and endlessly calming. Tonight, we explore one of the most enchanting wonders ever uncovered in the silent depths of space. These are worlds shaped not by myth or fantasy, but by real forces of physics and chemistry, sculpted under pressures so immense and so ancient that carbon itself transforms into crystalline landscapes. They glow in the dark, almost like cosmic lanterns, reminding us that even in the farthest reaches of the galaxy, beauty takes forms we can hardly imagine. In the dreamlike hush of this moment, we'll wander through their origins, their shimmering surfaces, and the stories they tell about how the universe works in its slow, patient way. Before we drift too far, feel free to gently like this video, subscribe to the channel, or leave a quiet comment if the mood moves you. You can do it now, before sleep begins to cradle your thoughts and soften the edges of the day. Once you've done so, you can simply relax into the journey. Let's begin. In the quiet vastness beyond our solar system, among stars that burn with unfamiliar hues and constellations that twist in shapes we do not see from Earth, astronomers have discovered planets unlike anything imagined in centuries past. They orbit their stars in tight, glowing arcs, worlds sculpted from carbon-rich material left behind by ancient stellar ancestors, and under the immense weight of their own gravity, that carbon undergoes one of nature's most extraordinary transformations. Instead of forming mountains of rock or seas of water, these planets compress their carbon into diamond, not delicate gemstones like the ones found deep inside Earth, but entire planetary mantles of crystalline solidity, glinting beneath atmospheres shaped by exotic chemistry. The first time astronomers suggested such a planet might exist, many were unsure how to even imagine it. The world known as 55 Cancri E, a super-Earth roughly 40 light-years away, ignited public curiosity because early research hinted that its interior could be rich in carbon enough, if conditions were right, to form vast layers of diamond. Though later studies suggested its composition might be more varied and complex than a pure gemstone sphere, the stir it caused awakened a shared fascination. The realization that somewhere in the dark, there may be planets where the crust is dominated not by silicate rock but by glittering, crystalline carbon, worlds where mountains might rise as faceted ridges, catching the star's light in endless reflections, worlds where the very ground could feel as if it were sculpted from solid night. In the stillness of evening, it's soothing to imagine the formation of such worlds unfolding at a pace so slow it almost seems like the universe breathing. Long before a diamond planet becomes what it is, it begins as a swirling cloud of dust and gas surrounding a young star, a nebular cradle where carbon, oxygen, and other elements drift like powder in a sunlit room. Over time, gravity gathers this dust into clumps, and clumps into larger bodies. On Earth, this process gave rise to familiar landscapes of basalt, granite, ocean, and life. But near certain stars, Especially those richer in carbon than ours, the same process yields very different results. Instead of silicon-based rock, carbon becomes the dominant ingredient, and under the intense interior pressures of a super-Earth, carbon doesn't stay in its soft, graphite-like form. It compacts, it rearranges, it crystallizes. Pressure has always been one of the universe's most powerful sculptors. Deep beneath Earth's surface, carbon slowly transforms into diamonds across millions of years, one atom locking into place after another, shaped by forces too vast for the human body to endure. But on a diamond planet, these pressures are not confined to narrow veins beneath ancient volcanoes. They exist across the entire globe. The whole world becomes a forge, a place where carbon is not a rare treasure, but the very foundation of the crust and mantle. In this way, diamond planets are reminders of just how varied planetary chemistry can be. Each world in the cosmos is a kind of experiment, running quietly and tirelessly for billions of years, revealing what matter can become when given enough time and enough force. As your mind wanders through this quiet cosmic landscape, you may imagine drifting between stars on a gentle path carved by their gravitational pull. One of these stars might be the one that hosts a diamond planet, a sun burning slightly brighter or dimmer than our own, its color perhaps more golden or more orange, and orbiting close to it, sometimes so close that a year passes in only a few hours, is the planet itself, glowing faintly from the heat that rises through its surface. Though such a world might be far too hot for life as we know it, imagining it does not require fear or urgency. Instead, think of it as a furnace of creation, a place where carbon's strength and stability are tested in the most elegant way the cosmos can offer. The planet's surface might shimmer with molten minerals, its sky hazy with vaporized elements, its horizon bending under the weight of gravity. The heat would be intense, but imagined from afar, it becomes something like a slow, radiant pulse in the dark, a reminder of the energy that fuels the universe from the inside out. As you picture these distant realms, let your shoulders soften a little. Space itself is almost impossibly calming when you step back and consider how it stretches in all directions, vast and quiet. Without hurry or strain, the light from a diamond planet's star travels for decades before reaching Earth. The photons that touch your eyes, or the sensors of telescopes tonight, may have begun their journey before you were born, passing through clouds of dust, weaving between other planetary systems, crossing empty gulfs where nothing stirred but the occasional whisper of radiation. In this way, observing a diamond planet is like looking into a memory the universe has carried across unimaginable distances. There is no rush, no noise, no turbulence, only the slow, steady travel of light across time. Astronomers detect planets like these not by visiting them, but by studying the soft dips in starlight that occur as a world passes briefly in front of its star. It's a subtle method, a technique known as transit photometry, requiring patience, precision, and the kind of quiet attention that mirrors the calm with which we watch the night sky. When a star's brightness dims by a fraction of a percent, astronomers learn about the size of the planet. When its spectrum shifts, they learn about its atmosphere. And when the data hints at unusual compositions, when the density comes back higher than expected, when the chemistry suggests carbon dominance, they begin to wonder whether they are seeing the signature of a diamond planet. This sense of wonder is something humanity has carried for as long as we have told stories about the heavens. Ancient cultures imagined jewels embedded in the sky, glimmering across the firmament. Some described the stars as diamond dust scattered by divine hands. Others believed the heavens contained celestial gemstones whose light passed down to earth as a gift. Now, with modern instruments and quiet patience, we find that some of these myths echo something real, not literal, diamonds twinkling in the sky, but planets where carbon crystallizes into unimaginable volumes of gemstone material. It's as if the universe had been hinting all along that beauty exists in places far beyond our reach, waiting to be discovered not with fantasy but with gentle attention. The existence of diamond planets encourages us to expand our sense of what is possible. They remind us that our solar system is just one arrangement among countless others. If a world can form from carbon-rich dust and become a sphere of crystalline solidity, then in other corners of the galaxy there may be planets composed largely of ice or metal or exotic substances we do not yet have names for. Each world is shaped by the star it orbits, the materials it inherited, and the pressures it endured. And in this way, planetary formation becomes not just a mechanical process, but a kind of cosmic artistry. Stars, after all, are the forges where carbon itself is made. When massive stars reach the end of their lives and collapse into supernovae, they scatter carbon across space. That carbon becomes the basis for diamonds on Earth, for the graphite in pencils, for the molecules that shape our bodies, and for entire planets that shine quietly in the dark. Imagining the birth of such a planet unfolds like picturing a slow dance of dust and gravity. You can almost see the young star lighting up the nebula around it, igniting pockets of matter that swirl gently into disks. Within that disk, carbon grains merge, forming pebbles, then stones, then larger bodies. The gravity of these bodies pulls in more and more material until the mass becomes great enough to form a planet. Over tens of millions of years, the interior compresses, heat rises, elements rearrange into new states. Diamond layers form deep below the surface, locked into place by pressure that never relents. Though the surface may transform through volcanic activity or tidal forces caused by the star's pull, the interior remains a monument to carbon's resilience, a crystalline memory of the forces that shaped it. To drift through these thoughts is to drift through deep time. Here, there is no need to hurry. You can imagine the planet cooling slightly over eons, or perhaps heating again as its orbit shifts or its star evolves. You can imagine the diamond layers forming new patterns, new fractures, new veins of graphite or carbide that trace delicate maps through the mantle. Everything in such a world happens slowly, patiently, as though governed by the universe's own steady heartbeat. And as you listen, letting your mind move like starlight through these ideas, you might find a sense of stillness emerging, a sense that the cosmos is not something chaotic or intimidating, but something vast and gentle in its slowness. The stars take their time, planets take their time. Even diamonds, whether beneath Earth or across the galaxy, need time, pressure, and patience to become what they are. They offer a kind of quiet metaphor, a reminder that beauty often forms under pressure, and that the universe is full of slow, deliberate processes unfolding quietly in the dark. And here, in this calm moment, you are part of that quiet unfolding too. The same carbon that crystallizes into these distant planets is present in your own body, moving through your breath, your heartbeat, your thoughts. The connection is subtle but undeniable, a soft thread linking you to the stars through the materials that compose you. As you imagine these worlds glinting far away, you're also imagining the origins of something within yourself, something ancient and shared across all of space. In this gentle beginning of our journey, the diamond planets remain distant lights, shimmering softly as we drift past them in thought alone. Their surfaces glow with heat, their cores shimmer with crystalline complexity, and their atmospheres hint at chemistry we are only just beginning to decipher. Yet their greatest gift is the sense of calm fascination they inspire, as a reminder that the universe, despite its immensity, is full of quiet wonders that reveal themselves slowly, like pages turning in a book written in starlight. As the night deepens, we will travel further into their stories, exploring how they form, what they may look like, and what they whisper about the nature of matter itself. But for now, let this gentle introduction settle around you like a soft, velvety shadow. You are safe here, drifting through thoughts shaped only by curiosity and wonder, floating in the slow, tranquil river of the cosmos. As we drift deeper into the quiet cosmos, the glow of those distant diamond worlds settles in the imagination, like stardust finding its place on a still surface. The night around us widens slowly, opening into a serene expanse where time feels stretched and unhurried. Here, the story of carbon continues to unfold, revealing how the same element that shapes these exotic planets also threads through the wider architecture of the universe. In this gentle space, we float in a kind of slow orbit around the idea of these crystalline worlds, watching as layers of understanding peel back in a delicate, unhurried rhythm. To truly appreciate what makes a diamond planet so extraordinary, it helps to return for a moment to the heart of planetary birth. The early solar systems that harbor such planets are often rich in carbon from the very beginning. A star forms from clouds of hydrogen and helium, but woven among these gases are heavier elements, the ashes of older stars that lived and died before. Some of those ashes are carbon atoms scattered after ancient supernovae. As they drift and collect, they seed the nebula with potential. What emerges from these remnants depends on the balance of elements present. A nebula rich in oxygen gives rise to worlds like Earth, with silicate, crusts, and oceans of water. But a nebula rich in carbon may form planets whose foundations are entirely different. In carbon-heavy regions of space, the ingredients for diamond worlds are already waiting long before the first spark of a new star takes hold. Within these protoplanetary disks, particles gather in spirals, clumping together over unimaginable stretches of time. Gravity performs its patient, quiet work, pulling dust grains into pebbles, pebbles into rocks, and rocks into planetesimals. These planetesimals, the building blocks of planets, collide gently or violently depending on their orbits. Sometimes they merge, sometimes they shatter, but always, in the background, the forces of pressure and heat continue their steady shaping. For a carbon-rich world, this means that deep within the growing planet, carbon is already beginning to arrange itself in new ways. Graphite softening into diamond under crushing weight, chemical bonds shifting and locking into beautiful crystalline lattices. Even the smallest fragments of a newly forming diamond planet hold the quiet promise of brilliance. When such a planet grows massive enough, its interior begins to resemble a grand geological engine, powered by the intense gravitational squeeze unique to super-Earths. These planets often possess far greater mass than Earth, sometimes 8 or 10 times larger, which means the pressures in their interiors soar to levels capable of forging diamonds on a planetary scale. Imagine the core of such a world, not a fiery metallic sphere like Earth's, but a deep, dense domain where carbon transforms into structures that glitter invisibly in the dark. If one could descend through their crusts, the layers might transition from graphite-rich regions to thick, coherent diamond forms, each layer shaped by a different combination of temperature and pressure. The deeper the descent, the more tightly packed the carbon becomes, forming a kind of crystalline mantle that glints and reverberates beneath the surface. Yet despite their beauty, the surfaces of diamond planets may not resemble sparkling gemstone fields. Many of these worlds orbit perilously close to their stars. In the case of 55 Cancri E, its orbit is so tight that the entire planet is tidally locked, meaning one hemisphere eternally faces the star while the other lies in permanent night. The day side may reach temperatures comparable to molten lava on Earth, hot enough to vaporize minerals and send streams of glowing gases into the atmosphere. The night side, shielded from the star's fierce light, might be cooler but still inhospitable, a realm where exotic compounds condense and solidify in strange patterns. Under such extreme conditions, diamonds may form not as sparkling fields, but as buried layers beneath molten surfaces, concealed beneath rivers of hot silicates or volcanic plains of carbon compounds melted into unfamiliar shapes. Still, the idea of these glowing surfaces invites a gentle visualization. You might picture the horizon of such a world in soft, dreamlike colors. Instead of the blues and greens of Earth, imagine a shimmering band of molten orange and deep crimson. Vaporized rock lifts into the air like luminous mist, shimmering faintly beneath a star that fills half the sky. This star would shine far brighter than our sun appears to us, because the planet orbits so near, yet the light, when imagined from afar, feels less harsh and more like the comforting glow of an ember. You are not standing on the surface, but floating in thought above it, peaceful and safe, observing the quiet artistry of a planet shaped by forces too old and too gentle in their patience to stir fear. Such worlds often experience phenomena unknown on Earth. For instance, the interplay between heat and pressure can create mineral atmospheres, where substances we know as solids become gases that cycle between sky and surface, like the water cycle on Earth. On a diamond planet, graphite might evaporate on the scorching day side, drift on high winds, and condense on the cooler hemisphere, falling like dark snow that settles quietly across the landscape. Volcanoes may spew out carbon compounds in glowing fountains. In this slow cycle of transformation, the planet breathes in its own unique rhythm, distinct from anything familiar, yet soothing in its consistency. When astronomers observe such worlds from Earth, they do not see these landscapes directly. Instead, they measure subtle shifts in starlight, Instruments aboard space telescopes detect tiny variations in brightness when a planet transits its star, and from those variations, scientists infer density, composition, and orbital behavior. In some cases, they detect infrared light emitted from the planet itself, providing hints about surface temperature. These signals are faint, like whispers carried across 40 light-years of empty space, and yet, even these whispers are enough to reveal entire worlds, turning distant light into stories. There is something deeply comforting in the idea that the universe shares its secrets slowly, quietly, without ever needing to rush. This measured pace matches the calm rhythm of the night. As we continue drifting through the story of these diamond worlds, their distances become part of their beauty. 40 light-years, after all, is a distance the human mind can barely grasp. Light, traveling at nearly 300,000 kilometers per second, needs 4 decades to cross that gulf. If you imagine a single photon leaving the surface of the star 55 Cancri A when you were a child, only now would it be reaching Earth to whisper news of the diamond-rich world orbiting it. That same journey will continue long after we finish speaking tonight, meaning that every glimpse we take at diamond planets is truly a glimpse into the past. This soft temporal delay adds a dreamy quality to their study, as though we are seeing them not as they are now, but as they were long ago, suspended in time like memories preserved in crystal. Even the notion of interstellar travel feels gentle and meditative in this context. Rather than imagining rockets or engines, picture the voyage through space as drifting on a calm, dark ocean. The stars move slowly above you, while a diamond planet glows faintly ahead like a lantern rising through fog. You approach not with urgency, but with drifting curiosity, knowing the journey is impossible in reality, yet soothing in imagination. This is the gift of astronomical distance. It invites contemplation instead of ambition, allowing the mind to explore without the pressure to arrive. As we linger here, you may let your breath ease into a slower rhythm. The calm expanses of the universe have a way of encouraging the body to settle, mirroring the steady pulse of stars that burn for billions of years. Among those stars, some are known as carbon-rich giant stars that have dredged up carbon from their interiors and scattered it into space. These giants play a crucial role in the story of diamond planets. The material they expel becomes part of the nebulae that later form new stars and planets. In regions where carbon outnumbers oxygen, carbon-based chemistry becomes dominant. Instead of water-rich atmospheres or silicate crusts, these worlds lean toward carbides, graphite, and potential diamond layers. The diversity of planetary types speaks to the incredible variety of cosmic conditions, each combination of elements and energies producing its own geological poetry. Many planetary systems host multiple worlds that differ in composition. In the 55 Cancri system, for example, several planets orbit the star, each with its own mass, orbit, and atmosphere. Some are gas giants, some are rocky, and one, the super-Earth 55 Cancri E, stands out as a candidate for carbon-dominated composition. This diversity mirrors what we see in our own solar system, where Mercury's metal-rich core, Venus's dense atmosphere, Earth's life-bearing surface, and Jupiter's churning hydrogen storms reveal nature's ability to sculpt a variety of worlds from the same raw materials. Diamond planets are simply one more example of this cosmic creativity, a reminder that beauty takes many forms depending on the conditions that shape it. Imagining these planetary families leads naturally to imagining the evolution of their stars. Stars themselves are slow storytellers. Over billions of years, they shift from youthful brightness to mature stability, then eventually into gentle dimming. The planets that orbit them are influenced by this long, quiet evolution. A diamond planet might begin its life cooler, more stable, only to become hotter over time as its star brightens with age. Or it might form close to its star from the beginning, locked in heat and tidal forces that sculpt its surface into molten flows. These long changes happen in rhythms so slow they make human lifetimes feel like brief sparks. Yet there is something soothing in recognizing that planetary worlds evolve just as we do, changing gradually, shaped by external forces, carrying the imprints of the environments in which they were born. As the night deepens, we drift further into contemplation of what such a planet might look like up close. Though the surface may not sparkle like a cut diamond, one can imagine crystalline structures beneath the crust that extend for hundreds of kilometers, forming vast interconnected lattices. These structures might channel heat through the planet in unique ways, creating temperature gradients unlike anything on Earth. In quieter regions, the crystallized layers may shift over geological timescales, producing quakes and tremors that send ripples across the surface. These tremors would not echo through rock, but through diamond, a medium through which vibrations could travel in sharp, clear patterns. The idea is calming in its precision. Entire seismic symphonies played out in crystalline worlds far from home. Even their atmospheres, though inhospitable, can be imagined in gentle detail. On some diamond planets, the skies might take on smoky hues from vaporized carbon compounds, creating dusky gradients instead of familiar blues. When the star's light hits these gases, the sky might glow deep amber or faint gold. On the night side, the sky could appear darker than coal, a breathtaking blackness where stars burn with knife-edge clarity. These imagined colors carry no threat. They emerge like brushstrokes in a cosmic painting, soft and fluid in the quiet theater of the mind. If one could hover above such a world safely, perhaps in the comfort of an imagined craft that drifts slowly like a feather in the air, the view might resemble a glowing ember in a vast fireplace of stars. The heat radiating from the day side would shimmer like a living aura, not fierce or frightening from a distance, but warm and steady. The night side, in contrast, would feel tranquil, a hemisphere of shadow where the quiet chemistry of carbon unfolds like a nocturnal garden. The boundary between day and night would create twilight bands where minerals condense out of the atmosphere, forming glittering sheets or crystalline frosts that coat the terrain. These delicate features would vanish each time the world rotates, renewed again and again across countless orbits. This slow, cyclical transformation reveals something profound about diamond planets. They are not static jewels, but dynamic worlds with geological lives all their own. Beneath their surfaces, diamonds form, break, reform, and shift with the planet's tides and internal heat. Carbon compounds rise and fall in the atmosphere, creating chemical cycles that echo the rhythms of weather on Earth. These planets breathe in temperatures and pressures instead of air, their motions dictated by the same universal forces that shape all matter. In this way, They remind us that even the most alien environments share a deep kinship with the processes we see at home, simply expressed through different elements, at different scales, under different conditions. As we drift in these thoughts, gently orbiting the idea of these crystalline worlds, the vast distances between us and them become a kind of cushion. Their remoteness ensures that our contemplation remains peaceful, free from urgency or concern. They exist for us only as light, as possibility, as quiet marvels shaped by the same cosmos that shaped us. And in the space between our world and theirs, there is only the soft, endless dark, not empty, but serene, filled with the faint glow of stars and the slow pulse of galaxies. We float in that dark now, carried by curiosity, guided by the quiet certainty that the universe holds more wonders than we will ever fully understand. Yet understanding is not required to appreciate beauty. Much like a gemstone held up to the light, diamond planets invite us to admire their existence without needing to claim them. They shine in their distant orbits, untouched, unvisited, and perhaps unvisitable. And in that unreachability lies a kind of peace. They remind us that some treasures are meant only to be seen from afar, like the glimmer of starlight on a calm sea. As the story continues in the next part, we will drift further into their mysteries, exploring what these worlds mean not just scientifically, but philosophically, and what they whisper to us about desire, restraint, and the way beauty shapes our dreams. But for now, rest in the calm glow of these diamond worlds, drifting quietly in the vast, starlit dark. As we drift further into the soft, cosmic quiet, the presence of diamond planets lingers like a distant shimmer, a soft reflection suspended in the dark. Their glow may be imagined rather than seen, a calming illusion shaped by science and gentle curiosity. They feel as though they float on the edge of awareness, beckoning us to explore more deeply the wondrous pathways of carbon, pressure, and time. In this stretch of the journey, our thoughts drift into the inner workings of such worlds, the slow movement of heat through crystalline mantles, the whisper of seismic waves passing through diamond layers, the delicate balance between the planet's orbit and the star it circles. Everything unfolds in a rhythm as unhurried as the night itself, as though the universe were breathing steadily around us. Each diamond planet carries a geological identity sculpted by its internal forces. On Earth, tectonic plates shift across a molten mantle, mountains rise over millions of years, and volcanoes build islands grain by grain. But in a planet rich in carbon and compressed to extraordinary densities, geology becomes something subtler, steadier, and perhaps stranger. In some models, the crystalline interior may be so rigid that tectonic movement occurs in slow, resonant tremors rather than abrupt shifts. Imagine waves traveling through diamond vibrations that move with exceptional clarity, creating a kind of planetary ringing that resonates through the mantle. These structures could produce patterns of seismic activity unlike anything we have ever mapped or measured, the signals sharp and pure, humming through the crystalline depths with the precision of a tuning fork. It is a quiet music, unknown, yet beautiful to imagine. Over billions of years, such planets evolve as their stars change brightness, altering the delicate equilibrium of their surfaces. Diamond itself is stable under pressure, but as temperatures vary, its layers may shift, fracture, or metamorphose into new structures composed of carbon, and exotic compounds. In the scorching daylight side of a tidally locked diamond planet, these changes could occur rapidly on geological timescales, as carbon melts and recrystallizes in patterns shaped by shifting temperatures. On the night side, far cooler but still alien, the carbon layers might settle into forms that resemble dark, glassy plains. In this imagined twilight, the planet becomes a canvas of alternating textures, each shaped by the interplay of heat, pressure, and time. The slow pulsing of the star's warmth paints soft gradients across its landscape, not harshly but in gentle, cyclical transitions that become part of the world's identity. As you picture these processes unfolding, you may feel the space around you deepen with quiet. This geological evolution also reveals a deeper truth about the nature of carbon in the cosmos. Carbon is one of the most versatile elements in existence, capable of forming countless molecular structures, from delicate organic rings to the rigid lattice of diamond. On Earth, it forms the backbone of life, cycling through forests, oceans, and the very air we breathe. In the hearts of stars, carbon emerges from nuclear fusion, forged in the intense pressures that convert helium into heavier elements. And in carbon-rich planetary systems, this same element takes on a geological role, shaping entire landscapes and interiors. The carbon that forms a diamond planet is not different from the carbon in your own body. It is simply arranged differently. Knowing this creates a sense of connection so soft and profound that it seems to hum in the silence of your thoughts. The formation of diamond planets also depends on the balance between carbon and oxygen in their planetary nurseries. If oxygen were abundant, the carbon would likely bind with it to form carbon dioxide or other compounds, following the pathways familiar to terrestrial chemistry. But in systems where oxygen is scarce, carbon remains free to form carbides, graphite, and diamond on enormous scales. In such environments, the processes that lead to diamond formation are not isolated anomalies, but the natural consequence of chemistry unfolding under the right conditions. These chemical balances shape the destiny of entire worlds, and just as small choices accumulate into great transformations in our lives, tiny differences in elemental abundance ripple outward over eons to sculpt a planet's form. The influence of a planet's star extends far beyond light and heat. Stars shape the internal rhythms of their worlds through gravitational interactions that generate tidal forces. In tightly orbiting planets like 55 Cancri e, these forces are immense, stretching and compressing the planet over each orbit, producing internal friction that generates heat. This tidal heating can cause the interior to melt, creating a dynamic balance between solid and molten regions. The molten areas may flow slowly, circulating heat toward the surface like deep, glowing currents beneath a crystalline crust. In this way, the star becomes a sculptor, its gravity shaping the very heart of its orbiting planet, stirring its internal layers like a gentle but persistent pulse. This tidal activity can also influence a planet's atmosphere. When carbon-rich materials heat up, they release gases that form exotic atmospheres dominated by compounds such as carbon monoxide, methane, or vaporized silicates. On the day side of a diamond planet, these gases may swirl and churn in slow, dense currents, shaped by the intense heat. On the night side, they cool, condense, and drift downward like mineralized fog. This cycle, though far removed from the water cycle on Earth, is soothing to imagine a quiet exchange between sky and ground, a soft breath exhaled by the planet itself. These atmospheric flows might produce shimmering halos around the planet, ribbons of vapor rising from glowing fissures, or vast, gentle storms of carbon compounds drifting across the surface in slow waves. The winds, though fierce by earthly standards, can be visualized in a tranquil, abstracted way, not as violent forces, but as fluid motions tracing elegant patterns across a world suspended in perpetual twilight. These imagined storms carry no threat, only the soft poetry of motion, shaped by natural forces that have existed for billions of years. In the wider context of the cosmos, diamond planets form only one part of the spectrum of exotic worlds. There are planets made entirely of ice at temperatures near absolute zero, planets with iron surfaces so hot they melt into liquid metal, and planets whose skies rain glass or whose clouds contain crystals of ruby and sapphire. Each type reveals a different reaction to the ingredients and pressures of its environment. Diamond planets simply express the potential of carbon under immense pressure, a quiet reminder of the universe's endless capacity for variation. The diversity of planetary types assures us that the cosmos is far more imaginative than we can ever fully picture, creating worlds shaped by beauty, practicality, and physics in equal measure. Yet there is something especially soothing about diamond planets. Perhaps it is the contrast between their extreme nature and the calm they evoke when contemplated from afar. Though their surfaces may glow with rivers of molten carbon, though their gravity may crush anything human, though their atmospheres may shimmer with unfamiliar compounds, their existence feels tranquil in its distance. They remain unreachable jewels, worlds that encourage reflection instead of ambition. Their silence is absolute, unbroken by wind, water, or life, a cosmic stillness that mirrors the quiet we seek when night settles around us. And in that stillness lies an opportunity to consider what these worlds mean, not just scientifically, but philosophically. Throughout history, humans have assigned meaning to gemstones, symbols of purity, clarity, endurance, or strength. Diamonds, in particular, have been linked with permanence, resilience, and the ability to withstand pressure. When one imagines entire planets made of diamond, these qualities expand into a cosmic metaphor. The universe itself becomes a jeweler, crafting crystalline spheres under immense forces, shaping them slowly over eons. These planets embody the idea that beauty can arise from pressure, that endurance and transformation are woven into the fabric of matter itself. They remind us that extraordinary forms often emerge from the quiet persistence of natural processes. The idea that some planets are made of diamond also touches on the ancient human desire to reach for the unattainable. For centuries, stories have told of distant paradises, hidden realms, and celestial treasures beyond human grasp. Diamond planets echo those myths, shimmering worlds too far to reach, too hot to touch, too distant to claim. Their unreachability becomes part of their allure, inviting contemplation rather than conquest. In this way, they gently encourage a shift from wanting to possess beauty towards simply appreciating it. The universe holds these crystalline worlds not as prizes, but as quiet reminders that not everything that shines is meant to be held. If one were to drift in imagination alone above the night side of such a planet, the view would be serene beyond measure. The star it orbits would hang on the horizon like a golden ember, illuminating the edge of the planet with a soft corona. The darkness below would stretch out as a calm, endless landscape, punctuated only by faint glimmers, where molten carbon occasionally peeks through the crust. The stars beyond would appear sharper, more numerous, filling the sky with a clarity untouched by atmosphere. The silence would be complete, a stillness made of vast distances and ancient light. This imagined perspective, though impossible in reality, offers a kind of emotional solace. It is peaceful to picture yourself floating there, weightless, detached from urgency, held in the gentle curve of space. Even more soothing is the knowledge that diamond planets, for all their exotic nature, are governed by the same physical laws that shape our world. Gravity, pressure, heat, and atomic bonding, these forces operate universally, weaving threads of consistency throughout the cosmos. In understanding diamond planets, we come to appreciate the unity of these laws, the way they bind the universe into a coherent whole. Everything, from the smallest grain of carbon to the largest galactic cloud, follows these principles. This unity creates a sense of belonging, a soft understanding that we, too, are part of this vast, interconnected tapestry. As we gently navigate these reflections, the scale of the universe stretches around us like a great cosmic quilt. Billions of stars, millions of planetary systems, uncountable worlds, and within them, innumerable expressions of matter shaped by time and pressure. Diamond planets are but one of these expressions, a rare but natural outcome of carbon's potential. Thinking of them is like holding a small piece of the universe's creativity in your mind, admiring its patience and its quiet artistry. And so we drift, unhurried, through this grand and gentle narrative. The light from diamond worlds continues its journey through space, crossing the darkness with silent determination. The worlds themselves continue turning, melting, crystallizing, evolving under their stars, and we remain here, listening, imagining, feeling the calm of the cosmos settle softly around us. As we continue drifting through the quiet expanse of this cosmic night, the diamond planets that shimmer far beyond our reach begin to feel less like distant curiosities and more like gentle companions on this slow voyage. Their crystalline hearts, forged under pressures beyond imagination, seem to pulse softly in the dark, echoing the rhythms of deep time. In this next stretch of our journey, we shift from the mechanics of their formation to the wider significance they hold, not just as geological wonders, but as reflections of how the universe has shaped human imagination, longing, and meaning across centuries. It is remarkable how naturally these worlds invite contemplation. A diamond planet is at once real and dreamlike, rooted in astrophysical evidence yet capable of stirring feelings that transcend science alone. When astronomers first proposed their existence, many people responded not with purely technical curiosity, but with awe. Something about the idea of entire planets built from carbon crystal taps into ancient stories, forgotten myths, and the deep-seated human tendency to see symbolism in the sky. In this gentle darkness, we can explore why these worlds resonate so deeply and how they connect us with the long lineage of star watchers who who lifted their eyes to the heavens long before telescopes were ever imagined. Throughout history, societies across the world looked to the night sky and found meaning in the light scattered across it. Stars became the eyes of gods, tears of mythical heroes, or jewels embedded in the celestial sphere. In many traditions, the cosmos was envisioned as a grand tapestry woven from precious materials. Ancient Hindu texts describe the heavens as a realm where stars sparkle like gemstones along the robes of deities. Some early Chinese myths imagined stars as celestial pearls scattered across a great river of silver light. Even in early Western thought, philosophers compared the firmament to a dome inlaid with glowing stones. Though these images were symbolic rather than scientific, they reflect something enduring about human nature, our instinct to pair the distant and the precious, to associate the unreachable with beauty, purity, or transcendence. Diamond planets embody this symbolic pairing in an unexpectedly literal way. They show us that the universe, in its patient creativity, naturally produces worlds that align with some of our oldest stories. This does not mean those stories predicted scientific reality, but rather that the human mind, in seeking beauty, often intuits patterns that exist at deeper levels. When we imagine a shining celestial jewel, we are responding to a desire that is both mythic and universal. The desire to find light, meaning, or guidance in the mysterious expanse above. Diamond planets give that desire a form, rendering poetic metaphors into quiet, distant fact. Yet their beauty also lies in their distance. A diamond planet cannot be visited, at least not with any technology we can conceive of today. The light that reaches us from these worlds has traveled across decades of time and trillions of kilometers. This separation insulates them from being turned into objects of acquisition or extraction. In a world where natural resources are often harvested to exhaustion, where beauty is sometimes diminished by our attempts to claim or own it, diamond planets remain untouched. Their existence reminds us of the value of marveling without grasping, of observing without needing to possess. They offer a gentle lesson in the art of appreciation, the understanding that some wonders are meant to remain beyond human hands, existing purely as reminders of the universe's effortless artistry. This concept, too, has roots in philosophy. Some, they believed, were meant only to guide the spirit or broaden the mind. The Stoics wrote of the stars as symbols of order and perspective, encouraging people to contemplate them in order to expand their sense of place within the universe. The Taoist tradition speaks of treasures that lose their meaning when pursued directly, urging instead a soft, receptive stance toward beauty. Even in modern psychology, there is an understanding that awe of the quiet emotion that arises when we encounter something vast or incomprehensibly beautiful helps calm the mind, dissolve unnecessary worries, and remind us that we are part of something far larger than ourselves. Diamond planets evoke this feeling effortlessly. They are too distant to be pursued, too hot to stand upon, too massive for human exploration, and yet their existence soothes the imagination. They become gentle beacons, encouraging us to surrender, if only for a moment, the idea that everything remarkable must also be attainable. In this way, they subtly mirror the emotional landscape of nighttime itself. Just as night settles around us like a soft curtain, inviting calm but not possession, these planets remain present, yet unreachable, seen but not seized, admired from afar like lanterns shining across a quiet lake. In considering their significance, it becomes clear that diamond planets sit at an intersection between science and dream. They teach us about high-pressure mineralogy, tidal heating, atmospheric chemistry, and stellar evolution, but they also guide us toward broader reflections. They speak of patience, reminding us that their formation requires billions of years of pressure. They speak of transformation, showing how simple carbon, given enough time and force, becomes something dazzling. And they speak of resilience, holding their crystalline structure against the immense heat of their stars. These symbolic resonances are part of why they linger in the imagination long after the facts are understood. As we drift deeper into these reflections, it is gentle to imagine how such a world might appear in the eyes of different cultures. Suppose an ancient civilization had looked into the night sky and seen a bright star hosting a planet made largely of diamond. They would have understood none of the scientific details we know today. Yet the knowledge that something precious shimmered in the heavens might have shaped their myths in fascinating ways. They might have imagined a world of perfect clarity, a realm of spirits or gods, or a treasure crafted by celestial beings. They may have believed that the light shining from that star carried messages of purity or endurance. In this way, the discoveries of modern astronomy do not erase the poetic sky of the past. They enrich it, revealing layers of meaning that intertwine across time. Diamond planets also encourage us to reflect on the concept of value. On Earth, diamonds are coveted for their rarity. They symbolize wealth, status, or permanence. But in the cosmic context, an entire planet made of diamond dissolves these associations. When diamond becomes planetary in scale, its value shifts from economic to contemplative. The worth of the world lies not in its material, but in its existence in the improbable beauty that nature produced far beyond any human story. This shift invites a gentle re-evaluation of value itself. What makes a thing precious? Its rarity or its beauty? Its usefulness or its mystery? Diamond planets lean softly toward the latter, inviting us to appreciate value that is independent of ownership. Much of the universe's structure reinforces this idea. Stars burn regardless of who watches. Nebulae glow without intention. Galaxies spin silently across space, whether or not anyone observes them. The cosmic environment operates entirely outside human concerns. It allows us to step outside the pressures of daily life and enter a space where meaning is created through observation rather than acquisition. Diamond planets, in their quiet distance, offer a meditative kind of value, a value rooted in wonder, not desire. Moving closer once more to their physical reality, it becomes interesting to imagine the observational futures that may reveal more about these worlds. In the coming decades, more sensitive telescopes will examine their atmospheres, searching for chemical signatures that can confirm their carbon-rich nature with greater certainty. These instruments will look for the spectral fingerprints of vaporized minerals, for subtle variations in emitted heat, for the faint glow of molten surfaces. Each new observation will add a brushstroke to the portrait of these distant jewels. Yet even as the portrait grows more detailed, the worlds themselves may remain essentially unreachable. This combination of increasing knowledge paired with enduring distance creates a unique emotional experience. It allows us to deepen our understanding while maintaining the peaceful awareness that these planets will never be reduced to simple resources. There is also something comforting in the slow pace of these discoveries. Large space telescopes take years to design, build, and deploy. Data takes time to collect and interpret. Scientific consensus forms gradually through patient collaboration. This slow unfolding mirrors the pace of planetary evolution itself, reinforcing the idea that some processes are meant to take their time. Just as a diamond planet forms over billions of years, our understanding of it grows little by little, like a crystal gaining facets in the dark. In imagining the future of diamond planet research, we can also consider the philosophical questions that arise from their existence. What does it mean for a planet to have such an unusual composition? How does it expand our sense of what is possible in the universe? How does it reshape our understanding of planetary diversity? And perhaps more subtly, what does it teach us about humility? For every diamond planet we identify, there may be thousands more we cannot detect, hidden among the galactic currents. Their presence reminds us that the universe is filled with secrets far beyond our reach, and that our awareness of them depends not on mastery, but on attention. As this gentle reflection continues, the cosmic scenery around us feels serene and expansive. The stars shine with soft, unwavering patience. The darkness between them stretches like a velvety fabric, unbroken and comforting. In this vast stillness, the distant diamond planets become points of quiet fascination, glimmering softly in the depths of space. They guide our thoughts toward the closing arc of this journey, where we will soon arrive not at an ending, but at a peaceful settling, a gradual landing into stillness. Before that final descent, we can linger a while longer with the emotional resonance these planets evoke. Their crystalline forms remind us of the many connections between the cosmos and the human experience. Just as pressure turns carbon into diamond, pressure in life sometimes shapes clarity, resilience, or unexpected beauty. Just as diamonds form from long processes deep beneath the surface, personal transformations often occur quietly, out of sight, only revealing their brilliance long after they have settled. And just as diamond planets shine with light that has traveled across unimaginable distances, moments of insight or peace sometimes arrive from far away, within the mind carried from forgotten memories or long-held hopes. In this gentle way, the universe becomes a mirror. Its distant worlds reflect back the stories we tell ourselves about endurance, beauty, and time. They remind us that the elements composing our bodies were forged in ancient stars, and that the carbon we carry is the same carbon that forms diamonds on Earth and in the cosmos. The connection is intimate yet immense, bridging scales from the microscopic to the galactic. In contemplating diamond planets, we are not only learning about the nature of distant worlds, we are learning something about ourselves, the materials of our existence, and the long journey of matter through space and time. As the quiet of this moment deepens, the soft transition toward the conclusion begins to take shape. The narrative gently turns from the specifics of diamond planets toward the wider context of cosmic unity. Soon, we will drift into reflections on the universal carbon cycle, on the idea that everything familiar and everything distant is interwoven by the same elemental threads. And eventually, we will arrive at the closing thoughts of this journey, a calm, glowing farewell carried by starlight and quiet reverence. But for now, rest in this serene orbit around the diamond worlds. Feel the vastness around them, the quiet that surrounds their molten surfaces, the solitude in their locked orbits, the glimmer of their existence across the gulf of space. Let them shimmer softly in your thoughts as we prepare to enter the final part of our journey, where all these reflections will come together in one last, peaceful arc beneath the stars. As we drift into the final chapter of this quiet cosmic journey, the diamond planets that have guided our imagination begin to settle into the soft, velvety background of the night. They shine less as destinations now and more as gentle markers along a path that stretches through time, memory, and meaning. Their glow seems to pull backward, as though they are settling deeper into the tapestry of stars, becoming part of the quiet architecture of the cosmos rather than the centerpiece of our attention. The journey that began with curiosity now opens into something wider and more encompassing, a recognition that the entire universe, from its blazing stars to its crystalline worlds, unfolds in rhythms that invite rest, reflection, and peace. In this final stretch, we look beyond the diamond planets themselves and instead consider the grander context in which they exist. Every world, whether composed of silicate rock, shimmering diamond, frozen ice, or swirling gas, participates in a cosmic cycle that stretches billions of years into the past and future. The carbon that forms the core of these crystalline planets was once forged in the hearts of ancient stars that lived and died in spectacular fusion. When those stars reached the end of their lives, they spread their carbon outward in waves of stardust, seeding future generations of stars and planets with the raw materials for diversity. Diamond planets represent one possible expression of this ancient inheritance, a single variation in an endless symphony of cosmic outcomes. As we follow the threads of this story, we find ourselves returning again and again to the idea of connection, not only between worlds and stars, but between the universe and ourselves. The carbon within these extraordinary planets is the same carbon woven into the cells of your body, the same carbon that cycles through forests and oceans on Earth, the same carbon that forms the backbone of every molecule that carries life. In a sense, the diamond planets we've been visiting in thought are distant cousins of the matter that composes you. Their shimmering hearts and glowing surfaces are made from the same elemental material that supports your breath and heartbeat. This shared lineage is a quiet reminder that you are not separate from the universe. You are made from it, shaped by the same processes that carved mountains, ignited stars, and forged crystalline worlds. In this way, the diamond planets offer more than scientific wonder. They offer a gently expanding sense of belonging. When you think of them suspended in the stillness of their orbits, glowing in the light of their stars, you can also think of the long journey of carbon from the cores of ancient suns to the formation of planets, to the chemistry of life, and finally to the moment you are experiencing right now. The atoms that make up your body have traveled farther than any ship ever has. They have witnessed the birth and death of stars, drifted through nebulae, and merged into planets long before Earth existed. To rest in this awareness is to rest in the knowledge that you are part of the universe's story, a quiet continuation of cosmic history that stretches across unimaginable distances and timescales. As this understanding unfolds gently, your thoughts may wander to the idea of time itself, the slow emergence of worlds, the patient evolution of stars, the seamless movement of matter through cycles of heat, pressure, and transformation. Diamond planets remind us that the universe does not hurry. It does not rush to complete its creations or force its timelines into small spaces. Instead, everything unfolds in a natural rhythm, shaped by forces that care nothing for urgency. Thinking about this, you may feel the pace of your own thoughts begin to ease, settling into a gentler, slower drift. Just as diamond forms under steady, patient pressure, your mind can soften into stillness under the quiet influence of the night. The transitions that brought us to this point, from nebula to star, from dust to planet, from carbon to diamond, all happen in silence. Even the most dramatic events in the universe, like supernovae or the formation of black holes, unfold in cosmic quiet, inaudible across the vacuum of space. Silence is the medium of the cosmos, and in this silence, worlds like 55 Cancri E orbit steadily, their surfaces glowing with heat, their interiors shimmering with crystalline layers, their atmospheres cycling gently between vapor and condensation. The silence around them is not empty. It is filled with meaning, with possibility, with the slow unfolding of natural processes that continue whether observed or not. As we imagine drifting past such a world one last time, hovering in thought above its horizon, the glow that rises from its molten surface appears less like a fire and more like a soft pulse. The star it circles illuminates the atmosphere in warm gradients, deep amber shifting to muted gold. Vaporized minerals drift upward in slow motion, moving in patterns shaped by winds that have never touched human skin. From afar, these movements are not violent or chaotic. They are graceful, as if the planet is breathing in its own rhythm, a rhythm sculpted by gravity and heat rather than lungs. If we continue drifting outward, the planet becomes smaller and smaller. It joins thousands of other distant worlds, each with its own composition, its own temperature, its own story. Some are icy spheres locked in perpetual winter. Others are gas giants with glowing cores. Some may host oceans of methane, or clouds of sapphire, or storms of iron rain. Each one is a reminder that the universe is far more imaginative than the human mind can easily comprehend. And yet, in contemplating this diversity, we find peace rather than overwhelm. The vastness feels comforting, like a wide blanket of possibilities stretching over the darkness. The more one imagines these worlds, the easier it becomes to recognize a quiet truth. The universe does not exist to be conquered or owned, but to be witnessed. Its beauty lies not in what it can give us, but in what it can show us, the patterns, structures, and stories that unfold when matter is left to its own devices. Diamond planets are an example of this beauty. They do not exist for mining or exploration. They exist simply because the conditions of their birth made them what they are, and in their existence, they invite us to become observers rather than collectors. This shift in perspective becomes especially soothing as the night deepens. To imagine yourself floating among the stars, simply watching, simply being, is to allow the pressures of daily life to melt away. The cosmos does not ask you to solve anything, to fix anything, to hurry or to plan. It only asks you to watch, to feel, to breathe, and to drift. In the vast silence of space, even the idea of effort seems to fade. What remains is a sense of openness, a gentle expansiveness that welcomes every thought and lets it settle softly like dust. In this softness, we can return once more to the idea of carbon, the thread that ties together planets, stars, and life. Carbon is the storyteller of the universe. It carries the memory of ancient suns. It forms the backbone of life's complexity, and in the depths of diamond planets, it reveals its crystalline strength. When you contemplate these worlds, you are contemplating the journey of carbon itself, a journey that stretches from the hearts of exploding stars to the breath you inhale in this quiet moment. This continuity can be soothing in a deeply grounding way. It means that even as the universe feels vast and unreachable, you are already part of it. The same patterns that shape diamond planets shape you. The same laws of chemistry that form their crystalline layers form your bones and cells. You are a piece of the universe contemplating itself, a small consciousness woven from ancient elements dreaming of worlds that shimmer in the dark. This thought carries a gentle peace, the peace of belonging. As this sense of connection settles in, the narrative of diamond planets begins to merge with the wider narrative of the cosmos. Their shimmering surfaces fade into the background of countless other worlds, all drifting through space with quiet grace. The stars continue their slow burn. Nebulae continue their patient spiral. Galaxies continue their ancient dance. And in this harmony, you find a soft place to rest, a place where time slows, where the edges of thought grow loose, where the mind floats like a feather on still water. Soon, the journey will draw to a close, not abruptly, but with the same gentle pace that has guided us from the beginning. In the quiet between thoughts, you may feel a sense of drifting not through space now, but through the soft interior of your own mind, moving toward a state of rest. The diamond planets remain in the distance, not disappearing, but settling into the constellation of memories and images that the night weaves together. Their glow becomes a faint echo, a soft warmth, a reminder of the beauty that exists far beyond our reach but well within our imagination. As the last moments of this journey unfold, let the story of these crystalline worlds wrap around you like a comforting blanket. Let the patience of their formation, the steadiness of their orbits, and the quiet glow of their surfaces guide you gently into stillness. The universe holds its breath with you now. The stars shine with the same calm they have carried for billions of years. The night is wide, soft, and welcoming. And now, as we reach the final closing of this cosmic tale, let the images of distant diamond planets melt into the soft glow behind your eyelids. Let the quiet of the universe settle around you, drawing you into rest. Thank you for drifting through this journey, for letting curiosity and calm carry you across the starlit expanse. May the peace of these distant worlds linger with you tonight, holding you in a gentle, shimmering calm. Good night, dear listener. May you rest deeply beneath the quiet canopy of the stars,